The whole process of the ETC occurs in the mitochondria, specifically through the matrix and the inner membrane space. Steps prior to ETC that are performed to get the major amount of ATPs. This occurs through glycolysis and the Krebs cycle, which then leads to the ETC. ETC is made up of 6 hydrogens that flow through the 3 major complexes, each pulling 2 hydrogens from the matrix to the inner membrane space. They are then pumped through to the ATP synthase, where ATP is formed by the reactions of the ATP phosphate and hydrogen. The energy of the proton gradient is used to make ATP. When glucose is oxidized during glycolysis and the Krebs cycle, the coenzymes NAD and FAD are reduced to NADH and FADH2. Inside the mitochondrial matrix, the electrons from the NADH are transferred to the electron carrier coenzyme by NADH dehydrogenase, and the protons are transferred across the membrane to the inner membrane space. Coenzymes Q carry the electrons to the BC complex. As the electrons move from BC complex to cytochrome C, more protons are carried to the outside of the membrane. The electrons are also transferred from FADH2 to the coenzyme Q, with the protons being transferred across the membrane. Cytochrome C transfers electrons to the cytochrome C oxidase complex, where protons are also transferred to the outside of the membrane. Once all of the electrons have reached the cytochrome C oxidase complex, oxygen is brought to the cytochrome C complex, and water is formed as a product. The transferred protons generate a proton motive force across the inner membrane of the mitochondria. The proton motive force is the ATP synthase, where the hydrogens are brought back into the matrix where ATP is formed and the cycle repeats itself again. This is how the electron transport chain looks like in action. The NADH transfers the electrons through the complexes, pulling 2 hydrogens from each complex, allowing a total of 6 to be in the inner membrane space. These hydrogens will then flow through the ATP synthase, where they will form ATP from the ATP phosphate. For the summary of the electron transport chain, 1 NADH is equal to 3 ATPs, while 1 FADH2 is equal to 2 ATPs, and 2 hydrogens are equal to 1 ATP. All of these can be found from the very beginning of glycolysis to the Krebs cycle and end at the electron transport chain. Oxygen's role in ETC is that it is the final electron acceptor that allows the hydrogens to be pumped by pulling the electrons through the chain to avoid hydrogens to get backed up. It also makes H2O to create an unbalanced concentration of the hydrogen to maintain the constant action of diffusion.